Hey guys, if you were testing or anything, you can see kind of my notes from each of these questions, so feel free to kind of read through them. Let me know if you have any questions about the answers we got in class. Here's the first page. The second page I'm gonna talk through. We didn't cover in class. The third page, page 29. Here were the answers we came up with. Page 35. These were the answers we got. Right? Page 37, and this was the last page in the packet. Congratulations, guys. We finished reviewing the class. It's super exciting. So next class we're doing a practice test, looking over the reference sheet, and we're good to go, right? So let's do this last page and call it a night. All right, let's zoom in. It says, the figure shown in the shape is a piece Julia is welding together for a sculpture. What is the volume? All right, so I see three pieces. So piece 1 plus piece 2 plus piece 3 will equal our total volume, right? So the first item is, I'm not going to fall for this, right? The radius would be 2. So the center piece is pi radius squared h. So pi, 2 times 2 times a height of 12. Okay, what is the third piece? That's a cone. It has a radius of 2 and a height of, I got to think about this here. So if this radius is 2, this radius is also 2 from the center to any edge. So this would be 2 and 12. So the leftover is 21. Take away 2. Take away 12. Okay, so that makes that the height of my cone. So my cone is, this cone would be the area of the base, which is a circle, times the height divided by 3. So we have pi, 2 times 2 times 7 divided by 3. All right, now the last piece is my hemisphere, 2/3 pi radius cubed. Our radius is 2, so we have 2/3 pi, 8. 2 times 2 times 2 is 8. Now we'll use a calculator to approximate this value. Okay, so this might look a little fancy, but I'm going to factor out a pi. It technically will make it a little easier for me. So I got to take 2 times 3, so that's 16/3 plus 12 times 4. So that's 48, right? And then what is that? 4 times 28/3. 28/3. I'm going to add all that up and then multiply by pi to give a final answer. All right, so 16/3, 16/3, 5.3 repeating. 48, 28/3, 28/3, 9.3 repeating. So we're going to add these up. So what is that? 14.6 repeating plus 48 times pi. So what is that? 12. 62.6 repeating times pi. 62.66666 times pi. 196.87. 196.87. Would round up to 9. Nice. All right, let's check out the next one here. A cylinder has a volume of 300 pi. All right, the base has a circumference of 10. Okay, so circumference equals pi times diameter. So if it's 10 pi, that means that the diameter is 10 and the radius would have been 5. All right, so 5 times 5 times the height is 300 pi. So working backwards here, we get 25h is equal to 300. So we can divide by 25. And that should be times 3 is 12, right? 300 divided by 25. Nice. All right, we'll keep scrolling down here. Jeff is mailing a jar of jam to his grandma, and he finds a rectangular box just tall enough for the jam. All right, so here's his box. That's a prism. That's base times width times height. Now I'm having a little problem seeing these numbers. That's kind of unfortunate, right? I kind of need to know these numbers. I think this is 10. I think this is 15, and I think I have no idea what that number is. This looks like 5. Yikes, I can't see that number. Some of you might be able to read that a little bit better on your piece of paper. No clue what that is. Okay, so let's just play along. It says, Jeff's mailing the jar. He finds the box just tall enough. What expression represents the volume of the space? Okay, so we have to have the volume of our box. So the volume of the air has to be the volume of the box. Take away the volume of the sphere, right? Or excuse me, the cylinder. So the volume of the box is base times width times height. And I don't know what this is. Maybe it's just an H. Okay, maybe that makes sense. Okay, and then we need to subtract this out. Okay, so this would be pi. The radius is 5 squared, right? So 5 times the height of H. So this is what we get here. Now, which one looks the best? Okay, so let's keep going. 15 times 10 is 150. So I'm liking this here, right? H minus 25 pi H. And so it looks like I'm liking C even better because I can factor out an H on both terms and get 150 take away 25 pi H. I like it. All right, question number 1. A grain storage silo consists of a cylinder and a hemisphere. Okay. The diameter of the cylinder and the hemisphere is 20. So I'm not falling for that, right? That's going to be 10. Okay. The cylinder is, okay, so they give you that, right? The cylinder is 150 feet tall. Okay. What's the volume? So it's the volume of the total volume would be the volume of the hemisphere, 2/3 pi r cubed, and the volume of our cylinder, so pi r squared h. So we have 2/3 pi 10 cubed plus pi 10 squared times 150. So we get 2,000 divided by 3 pi and 150, 2 more zeros, pi. All right, so how could we combine that? It looks like everything over 3. We can turn these into decimals and compare the decimal value to each if you don't like combining fractions. Or I could multiply the top and bottom by 3 so that I have the common denominator 3. So I have 2,000. And factor out this pi, so that would be 45,000. That's a total of 45,667,000 thirds pi. Is that one of my choices? Yes, it is. Nice work, guys. All right, 3 more, and we'll call it done, right? Working our way back up this side. We have a width, and this is a triangular prism. What does that mean? It's made by stacking triangles of the same shape. So if we kept stacking triangles of the same shape. So the volume is the area of the base times the height. The base happens to be a triangle. So this looks slightly different than other shapes we've dealt with before, okay? Now it says Alice is shopping for cheese, and then this would just be a regular old prism or box. So this would be 10 times 3 times 4, or 120 centimeters cubed. She noticed that the cheddar and the brie have the same volume. Okay, so if this is 120, then we can set this equal to 120, right? So we have 120 is equal to the base, which we could call 3. The width we don't know, so we'll call W. And the height we stack this, which we'll call 10, and we want to divide by 2. So what number would give me? You could plug this in. If I plug in the number 2, do I get 120, right? If that doesn't work, plug in 4, do you get 120, right? Plug in 8, do you get 120? So I feel like if I plug in 8, I get 120. I'm kind of just plugging this in here. We could also use algebra to solve, right? So I could multiply 2 on both sides. And on the left, we get 240. On the right, we get 30W. And then I can divide by 30 on both sides, and we get 8. So my hunch was right. When I plug in 8, I get 3 times 8 is 24, times another 10 is 240. When I cut that in half, I get 120. So I know that's my right answer. All right, working my way up. The diameter of a basketball is approximately 9.5 inches. I'm not falling for that. I'm going to take 9 and divide it in half. 9.5 divided by 2. Okay, 475. So 4.75 is my radius. It says the diameter of the basketball is that, and the diameter of a tennis ball is 2.5. So that would be 1.25 for my radius. So I have a radius of a tennis ball and the radius of a basketball. The volume of the basketball is about how many times greater. So if I knew the volume of the basketball, what would I have to multiply? What factor? Right, I'll just call factor X, the X factor. What would I have to multiply that to get the volume of the tennis ball? Let's find out, okay? So I know the volume of the basketball would equal 4/3 pi 4.75 cubed. And here's my X factor times 4/3 pi 1.25 cubed. So if I notice here, I can divide by 4/3 on both sides, divide by pi on both sides. And the only thing left I have is this number equals X times this other number, okay? So we're going to figure out what those numbers are. So 4.75 cubed, 4.75 cubed, so 10717. So on the left, we have 10717 equals X times, and we're going to figure out what this number is, 125 cubed. 125 cubed. So 1953. 1953. Okay. So to solve this mystery, I'm going to divide on both sides. And this will help us get X by itself. Then we'll know what X is, right? So X is equal to those two numbers divided. So 10717. 10717 divided by 1953. 1953. I get 5487. 5487. So, pretty darn close to 55, isn't it? So how can we check this? Is 195 times 55 pretty close to 107? Let's check. 1.95 times 55. 1.95 times 55. Yeah, 107. Well done. Oh, last question. So exciting. The weight of helium in a balloon can be estimated by calculating the volume of a sphere with the same diameter as a balloon's width. Helium has a density of about this. What is the weight of the helium in a balloon with a width of 10 inches? Rounded to the nearest hundredth. So I need to know the weight. All right, so I know that I need to take this as ounces divided by feet cubed, and I need feet cubed to cancel. So that would be its volume. If I knew the volume, I could multiply, feet cubed would cancel, and I would be left with whatever my answer is in ounces. I'll round that to the nearest hundredth. So what could be the volume? If the width is 10, then that means the radius is 5. All right, so a sphere would be 4/3 pi, 5 cubed. And this would be in foot cubed, and foot cubed would cancel. So I need 1.165 times 4, enter, divide by 3, enter, times pi, enter, times 5 times 5 times 5. 8639. 8639 ounces, rounded to the nearest hundredth. There it is, guys. Hooray! Well done. See you next time.